Hi guys, it's Mrs. Wilson. I had to go to a meeting today at Central Office, and I hate to be leaving you, especially with it only being the 5th day of school. The expectations are the same as if I were there, so please be respectful of one another and the substitute, and I will be back tomorrow for our magic show. We're going to talk today about the scientific method. You should have a guided notes sheet in front of you. If at any time, if we don't get through all of the notes today, you're always going to store these in your notes section of your binder. And let's go ahead and get started. So we're going to talk about that first learning target today. I can identify the steps of the scientific method. You should have already been brainstorming that in your bell ringer, and hopefully you had some good conversation and you notice that maybe not everybody remembers every single step of the scientific method. So let's go through and let's figure out what is the scientific method. Okay, so the scientific method, and anytime I underline something up on the board, you probably have to fill it in. So it is a process, so I'm going to underline that. It is a process that is used to find answers to questions about the world around us. So you use the scientific method more than you probably realize. It's not just in the science classroom. It can be anything from a science experiment to, hey, why isn't my locker working? So you've got the scientific method, and you probably realized in talking in the bell ringer that there's not just one scientific method. So as you circle that question in your notes, is there just one scientific method? There's not just one. Okay, but they all do have in common at least one thing, whether you realize it or not, and that one thing is they all start with identifying a problem. So go ahead, and you should have that whole top part of your notes filled in. And at any point, if this video is going too fast for you, just respectfully raise your hand and the substitute can hopefully pause it for you so that everybody is caught up. Alright, so identifying the problem. So that's step one. So as you look at your notes and you find that box on the right hand side, step one is going to be to state the problem. So fill that in there on your notes. And essentially what you're doing when you state the problem is you're asking yourself, what do you want to know or explain? So earlier I said, why won't my locker open? Okay, that would be a problem. The key is the problem has to be written in question format. So you've already got that in your notes, but I want you to underline it, put a little star by it if you can. Okay, and so that's going to address the problem or the topic that you want to investigate. So the example that I've got for you, and the one that we're going to talk about through the notes, is, will giving plant food to a marigold help it grow faster? So take a minute, go ahead and copy down that example in your notes. Alright, so step two, as we go to step two and you fill that in your notes, that's going to be to research the problem. Now it might be that you are pulling back past information from your head. You might be pulling back past knowledge, or you might need to gather some new information about the problem. So if we're talking about where we get our information or where would you get it, you want to make sure that you're getting it from a reliable source. So things like articles, again, past experiences, library, the internet. You use all the time to look up things. So that would be a good way to research the problem. So your example that you're going to go ahead and fill in there is that the researcher reads articles about the best plant food. So we're getting some ideas as to which plant food we want to try in this case. So I'll give you a second to fill that in. Okay, so then step 3, as we go to the next step, it is to create a hypothesis. And a lot of you guys, as we were talking about inferences the other day, you were using that word hypothesis. Hypothesis and inferences work hand in hand. So what do you think will happen? You're just going to predict the answer to your question. So your hypothesis should directly answer your question. So if we're talking about that problem of why won't my locker open, your hypothesis would answer that. If I kick my locker, then it will open. Now, hopefully you're not kicking your locker. But it always needs to be in an if-then statement. So as I underline that, you need to find where it goes in your notes. We're in that third box on the right-hand side. And let's go back to our original example and our original question. Will giving plant food to a marigold help it grow faster? So an example of a hypothesis, and the example that I want you to write down, is if I give the marigold a teaspoon of plant food every other day, then the plant will grow better. Now, if you were actually doing this experiment, you might have a different hypothesis. As long as it answers that essential question in that first question we had, will giving plant food to a marigold help it grow faster? So I'll give you a second to finish writing that hypothesis in. Okay, now that we have an answer to our question, we have to find out if our answer is right. So step 4, what you're going to do is you're going to list the procedures. And you guys will be listing your own procedures. I'm going to give you an experiment in probably the end of this week, next week. You will need to develop a procedure. You don't want to leave out any steps. Okay, think about making a peanut butter and jelly sandwich, and if I told you to make a peanut butter and jelly sandwich, you're not going to just, hopefully you won't say, get the peanut butter, put it on the knife, and spread the peanut butter. If that was the case, and if you told me to do that, you didn't tell me to get out 2 pieces of bread, so I'm going to have a mess in front of me. So we always have to act like we don't know anything, and we can't assume anything. So you don't want to leave out any steps. Okay, so for your example, and I know this is a lot, so if we look, okay, I want you to just write, again, don't leave out any steps. So for in the example part, I want you to write, don't leave out any steps, and I'll save you a little bit of writing. But as we look and as you write that, my example there, if we were to be doing the marigold experience, we'd get several marigolds, we'd measure the marigolds and record. We give all but one a teaspoon of plant food, and we'll talk about why we don't give one a teaspoon of plant food here in a minute. We care for the marigolds normally throughout the process. Number 5, we're going to continue to give the marigolds food every other day for 10 days, except that one that we're not giving any plant food. And then number 6, we're going to record the growth each day for that 8 days. All right, so for the example, again, you should have written, don't leave out any steps. So that's step 4. We're going to go to step 5, and as long as we've got step by step, we're going to go to step 5. But before we do that, I jumped ahead there for just a second. Before we do that, we got to talk about the parts of the experiment. So we're going to go right directly over in your notes. We're going to go to that right-hand side where it says parts of the experiment, and every experiment is going to have these 4 parts, and this goes with your learning target. I can identify what independent variable, dependent variable, control, and constants are. So we're going to be doing several activities that test our knowledge on these 4 parts. Okay, so the first part of the experiment is I'm ahead. I'm going to jump ahead here and I'll come back. Okay, so the first part in your notes is the independent variable. It's going to be the variable that you change in the experiment. And you'll notice you don't have any place to write, but the key is you change it, and I've written out to the side in your notes, I change it. Okay, independent variable, it starts with an I, so we can think I change it. So when you're thinking about our marigold experiment, what do you have control over? What do I change? The example would be, okay, plant food. Is the plant getting plant food or not? So you can just write plant food for your example for independent variable. All right, now the next part of the experiment is the dependent variable. It's the response. It's what responds to what we change. So if we're giving the plant food, we gotta think, what am I measuring? What's responding? So in this case, we know if it's working by the plant height. So your example would be how tall the plant grows. When we start graphing results, and when you talk about graphing in math, those two things, independent variable and dependent variable, those are your x and your y axis. The independent variable always goes on that x-axis, and the dependent variable always goes on the y-axis. And we'll talk about that more as we go through. So let's go back to the other parts of the experiment. Let's talk about the control. Okay. We have to know if the independent variable works, and because of that, we have to be able to compare it to something. So out to the side, you'll see it, your note says control, the group that does not receive the independent variable. Okay, the key word for this, and I want you to write it out to the side, and I don't have my stylus, so you got to excuse my handwriting. Okay, the key word is compare. So make sure somewhere out to the side of that control you've got that word compare. We have a control because we compare. And your example, so we need to know if the plant food works or not. So we need to have a marigold that does not get the plant food. So fill that in for the example. All right, the last part of the experiment that every experiment needs to have and we need to consider is called the constants. Okay, you have to have some things that remain the same. We're testing the plant food, so we can't also change the amount of water that we give the marigolds. What do you think is going to happen if we change the water to each marigold? Do we know if the plant food's working or is it the water? We have to know that it's the plant food that's causing the plant to grow or not. So we have to keep everything else the same. So you might just want to underline that word same. So in our example of the marigold, you might keep all of the marigolds in the same pots. We want to keep the amount of the soil the same. We want to make sure the amount of plant food we're giving is the same. We should probably feed it at the same time. We want to make sure that it's sitting in the same spot. We don't want one in the windowsill and then one back in the closet where there is no light. And there are many other constants that we want to make sure, like we want to do all marigolds. We don't want to have 10 marigolds and 10 daisies or 10 tulips. We need to make sure that we've got some things that are staying the same because different plants might work differently with the plant food. All right, so there are your parts of the experiment, and as you're making your procedure and you're doing step 4, you're listing that procedure, you want to make sure that you're keeping all of those 4 things in mind, because when we're talking about the learning targets, yes, you need to know the parts of the experiment, but the key, probably most important, and the one that some of my 7th graders struggle with the most, is identifying things like the independent variable, dependent variable, control, and constant. So we're going to work on that the next several days. So if you do have questions about those, I want you going over those tonight And then we'll talk about those the next couple days, and I will be answering questions. So now that we have the procedure, now that we have all of the parts of the experiment, we're ready to go to step 5. And of course, that's probably the most fun part that you guys like to do. Okay, we're going to do the experiment or test your hypothesis. So that's step 5. Do the experiment. Now it's very important that we're following all of the steps, following the procedure. We need to make sure that we're following proper safety rules if given, depending on our materials. So as we go step by step, we need to make sure that we're doing it correctly, because that's the only way we're going to be able to get accurate results. All right, step 6. We're going to record and analyze our data. So what kind of results did we get? We need to record for the marigold. We're going to record the height each day. If we're going back to that locker example, it might be as simple as, did my locker open or did it not? So it depends on what the experiment is as to what kind of data you're actually collecting. Ultimately, and in science class, your data should always be in neat and organized tables or graphs. So as I underline it, make sure you're filling your blanks in, and we're on the right hand side there, step 6. Alright, so my table for the marigolds looks a little bit like this, and it was hard for me to get it all to fit on the slide. Notice at the top there I made a note. I didn't leave out my units. Okay, I made a note that it was all in centimeters. And right off the bat, I want you looking. Okay, so my control, it looks like through 8 days, it looks like my control didn't grow at all. Or I'm sorry, I'm reading that wrong. Okay, the control grew. It went from 1 to 1.4. Now when we look at the bottom there, most of all the others, it looks like grew a little bit taller, except for which one? Okay, this one right here still grew, but it only went to 1.42, and so that's when we got to start looking at what might have happened with that seventh plant. Okay, now if you remember, we said we were going to collect data for a lot longer, so this table isn't fully complete. All right, going to step 7, we're going to make and state our conclusion. So we need to write a conclusion that summarizes the important parts of your experiment and the results. What do you notice by looking at your data? Okay, and ultimately the main question that you're asking yourself, okay, is, was your hypothesis correct? So our example, and let's just jump to that example. And this is pretty vague. Yours should hopefully be more detailed, but I didn't want you to write a whole full paragraph. The marigolds that were given plant food grew taller than the marigold that did not receive plant food. And ultimately, for the most part, if you remember going back to that data, all of them grew taller than the control, except for one. So go ahead and fill that in. I'll give you some time. Okay, so this is where we have to go back, and if you follow your flow chart, I know there's a lot of arrows on your notes. You got to ask yourself, was your hypothesis correct? There's 2 answers to that question, either yes or no. Okay, so if the answer is yes, we're going to go off to the right side there, then our hypothesis is supported. Okay, so because of that, our hypothesis is supported. We still need to make sure that we repeat it, if at all possible, to make sure that our results are consistent and valid. If you remember that one plant didn't grow higher than the control, something I might have given it too much water or too little water on accident one day, that might have affected it. So I want to help make those results a little bit more consistent and more valid. Now let's say that the answer is no, my hypothesis was wrong. Maybe all the plants didn't grow as tall as the control. Then I have to go back to step 3. I need to make a new hypothesis, and I'm going to go back to step 3, and I'm going to have to redesign an experiment to test my new answer to the question. So in a perfect world with science experiments, you're going to do the science experiment several times. And when we talk about scientists throughout the year, all of these scientists that have been published and have all of these reports and statistics and facts did their science experiments over and over again. We're going to talk about Gregor Mendel towards the end of the year, and he studied different plants, and he worked with over, I believe it was 30,000 plants in his career, doing the same experiment over and over again and recording his results to make sure that his results were consistent. Okay, so hopefully as you look at your scientific method notes, hopefully you don't have any more blanks to fill in. If for some reason you do, you can look on with your shoulder buddy, work to fill in the blanks and the holes. This paper is going to go in your notes section of your binder. Please remember that your star is due on Thursday. And if you've got some extra time, depending on how long it took you to get through this video, if the sub had to pause it or not, if you have enough time, you may work quietly on your star. I will see you tomorrow for the magic show. So come with good observation skills, making sure you are ready to not only listen, but watch and watch closely, because you'll see some cool things. I hope that you had a good day, and I hope that I will have a good report when I return, and I will see you on Wednesday.